Our lesson for today is evaluating and or simplifying expressions that involve squares and square roots. I would like you to get your guided notes and follow along as we discuss this lesson. All right? Squares and square roots are just not a big words, because squaring a number is simply multiplying a number by itself. Like, for example, if I am going to square 4, I will just simply say 4 times 4, right? Now, there's another way of rewriting that. Squaring a number, instead of saying 4 times 4, we can say 4 raised to the power of 2. They mean the same thing. Okay, why is it called square or squaring a number? Because actually, when you get the area of a square with a 4 as its side, then that is squaring a number. Let us take, for example, if you have a square with a side of 4, then you are asked to get the area of the square. So what will you do? You square the sides, which is side times side, which is 4 squared. 4 squared is 4 times 4, and it is 16. 16 is said to be a perfect square. Why? Because this is the area of a square whose side is 4. Are there other perfect squares? Yes, they are. Like, for example, I have 1 times 1 is 1. 1 is a perfect square. If I square 2, which is 2 times 2, is equal to 4. 4 is a perfect square. If I square 3, 3 times 3, the product is 9, so 9 is a perfect square, and so on and so forth. 16 is a perfect square, 25 is a perfect square, 36 is a perfect square, 49 is a perfect square, 64 is a perfect square, 81 is a perfect square, and 100 is a perfect square. Why? Because these are the products of squaring some numbers. I did not fill up the other part of the table. Get the get your guided notes and fill up the second table. All right, pause your video, and I would like you to fill this up. All right, pause your video, get your guided notes, and fill this up. All right, let us continue on. What about if you are given a square with an area and you are asked to get the side of that square? What are you going to do? Since getting the side of a square given an area is opposite to given the sides and you get the area, we need to get the opposite operation as well. So what is the opposite operation of squaring a number? If the opposite of dividing is multiplying, the opposite of adding is subtracting, what is the opposite of squaring a number? That is getting the square root of a number. How do we do that? So let us get this square with an area of 36. All right. To be able to get the sign aside of this square, we get the opposite or inverse of squaring a number. And that is getting the square root, and the symbol of getting the square root is this symbol. We read it as the square root of a number. So, basing from that, how will I get the side of this square? You need to get the square root of 36. What do you mean by getting the square root of 36? Think of a number that when you multiply it by itself, it will give you 36. Will you be able to help me with that? What number should I multiply by itself to give me 36? You are correct. 6 times 6. So the square root of 36 is 6. That is the side of the square with an area of 36. 36 is also a perfect square, just like that of your 16 a while ago. And the square root of this perfect square, 36, is 6. All right? Okay, now let us try to simplify expressions involving squares and square roots. Let's take number 2. Yes, I skipped number 1 because I would like you to do that on your own. Okay? So let us see number 2. Parenthesis 2/3 squared. We can say that, okay, this means that we have 2 raised to the second power, 3 raised to the second power, and we can still simplify what it means by 2 to the second power, which is 2 times 2. I use parentheses for my multiplication. Then 3 times 3. Are we done? No, we're not, because we need to perform that operation. 2 times 2, which is equal to 4, over 3 times 3 is equal to 9. Can I simplify this? Or can I, if I divide this, 4 divided by 9, will it give me a whole number? No. And I cannot do it in its simplest form because that is already in its simplest form. So the equivalent of parenthesis 2/3 squared is equal to 4/9. All right. Now let us see number 6. Okay. Let us see number 6 is square root of 144 minus the square root of 36. Let us start with, what is the square root of 144? What two numbers should I multiply by itself to give me 144? And that is 12. So the square root of 144 is 12. Minus, what is the square root of 36? What two numbers should I multiply by itself so that I can get 36? 36 times 6. So this is 6. Are we done? Not yet, because there is still an operation that we can perform. 12 minus 6 will give me 6. And this is the simplest form of this expression, square root of 144 minus square root of 36. Okay, we're good. All right, let us see. Okay, I would like you to get your guided notes. You can find all of these numbers 1, 3, 4, 5, 7, and 8. I would like you to do it on your own. Not only on your own, you can seek help from your classmate. If neither of your friends around you can help you, you can ask me. Okay, pause this video, get your guided notes, and do this. Okay. You might be asking me, Mr. Mel, so if I know this, what is the use of this in daily life? Let us see this one. All right. We have a halftime performance of students who are 289. According to their PE teacher, they should form a square. They should position themselves so that they can form a perfect square. So let us see that. How many students should be lined up in each row? So if these are the different rows, columns, the columns and rows should be of the same number because it is a square, right? So how many students should be in different rows? Oh, a square. So meaning to say, that is how many students should be inside the square? It is supposed to be 289, you know? There should be 289 in all in the square. So how many will be in one row or in one column? So it's the same thing. Oh, this is the area of that square. So it is asking me what is the side of this square. So what will I do again? Oh, what's the opposite of getting the area is getting the square root of 289. So let us think of a number that when we multiply by itself will give me 289. Look at the chart that you just filled up. All right. Look at the chart that you have filled up, or look at on top of our board. Those are your perfect squares. Okay, so it is 17. There should be 17 students here going that way, and there should be 17 going this way. Right? Okay. Now let us see the last problem that we have in this. Oh, Allison has a square room. So let us put that. Oh, this is the square room of Allison. And it has an area of 144. It says there, what is the perimeter of Allison's room? Do you remember what perimeter means? Area is the space inside the square. The perimeter is if we add all these outside sides, this outside, how long will it be? So we should know what is this equal to because we need to add them, right? How do we get the sides of a square again? Correct. We need to get the square root of 144. What number should I multiply by itself so that it gives me 144? That is equal to 12. But that is only for one side. If it is perimeter, there is supposed to be four sides of a square. So we multiply this by 4, which is equal to 48. That is the perimeter of the room of Allison. Okay? This is the perimeter. This is the area. This is the side. And this is the perimeter. Okay? Do we have any questions? If you think you cannot understand, raise your hand and I will come to you. All right? So, our lesson for today is getting the square and square root of some numbers and in an expression. If you will be done with this guided notes, I would like you to go to your, we do not have Delta Math yet because you do not have your laptops. So I'm giving you paper for your skill drill and your guide, your mastery check is in your guided notes. All right.